Okay, I hope you don't mind if I sit down while I do this, because I'm not as good with my feet as I used to be. Okay. Is that just the size?
Yeah, they should bring that. There you go.
You know, you're not going too far. Sorry.
There's a slide delay. I think you've just got 2 slides.
I've got 2 slides, I know.
Which is the first one? That looks like.
Okay. Now, artificial intelligence research has involved chasing one heavily funded and overhyped paradigm after another, with intervening AI winters. A study of commercially unsuccessful projects can tell you a lot about the economics and political environment has decided which projects should get funded and which would be abandoned. Now, what I'm talking about is a project which I got involved in, which was abandoned, and which I am now trying to do. My background as a long retired project leader, I'm looking through the archive of this project, which closed simply because it did not correspond to the fashionable paradigm. I was effectively told when, to try and get some publicity, I produced a working demonstration of an educational package on a BBC micro. And I got rave reviews, New Scientist, Psychology Today, Time, Error, Educational Supplement, such like, and I pinned them on the notice board. Work. And I was told, take them down. You're bringing our department into disrepute. AI is all about getting grants for big computers. And at the time, to be perfectly honest, this is a personal matter, I was dealing with the problem of family suicide. And I decided to take early retirement rather than have a complete mental breakdown. That was why the project ended. And to say a bit more about myself, I'm neurodiverse. Autism caused a lot of problems when I was at school, although of course it wasn't diagnosed in those days. And I recently discovered I have aphantasia, which means I can't recall visual images. Which means that when AI started saying, oh, it's all about pattern recognition and reading text, it passed completely over me. And okay, so probably because I'm neurodiverse, I got involved in complex systems. And this is some of the ones I got involved in. The first one was for a PhD, and I was doing theoretical chemistry. Got some pretty horrific maths, quite a lot of statistics. And one of the real problems was that the theoreticians didn't understand experimental chemistry, the experimental chemists didn't understand theoretical chemistry, and they all liked to quote each other to show how clever they were. And that got me interested in scientific information. And so in 1962, I started work, and I was a graduate level clerk handling technical mail in an international research organization. In effect, I was acting as a human chatbot. Mail that was coming in, all the information coming in, I was responsible for archiving it and such like, answering questions, producing reports. I felt that computers might help. I knew nothing about them, but I came across the work of Vannevar Bush, who in 1946 wrote an article, As We May Think, and I decided to find out how computers could help provide better management information. I was also interested in the money. I wasn't being paid very well, and I moved what was, I now know, is one of the most complex batch sales accounting systems anywhere in the UK in the mid-1960s on Leo 3 computers. I suggested that the opaque and very complicated invoicing system for a million ever-changing sales contract rules, and sales contracts are rules. They're programs of how to price goods. And 5,000 products could be reformatted in a salesman-friendly and transparent form when terminals became available. Oh no, good salesmen don't understand computers. But I said, why don't we design computer systems they do understand? And was told effectively, you weren't want, I wasn't wanted. However, at this stage, I was headhunted to work on future top-of-the-range commercial management information systems by John Ellis, who was one of the Leo computer teams, who knew a lot about why Shell X and BP's system wouldn't work, or had difficulties. And I had the project started, it was called CODIL, Context Dependent Information Language, and it was a generic attempt to produce a transparent, interactive electronic clerk, which would handle a wide range of commercial and database-oriented tasks. Now, probably because computers were comparatively new in those days, and I was neurodiverse, I didn't think I was suggesting anything unusual. It seemed obvious to me at the time. And it was funded by David Cameron and Pinkerton, and work started in writing a computer simulation to show that a lot of the things worked. And it did work to the level of the original proposal. There was a problem. ICL was formed. And if any of you know anything about ICL, both Pinkerton and Cameron got sort of rather pushed to one side in the process. And I was in one of the research divisions, which was closed down. However, I was given, and I can thank ICL at least for this much. They gave me and at least one other researcher, and probably more, permission to take their research elsewhere. I still hadn't realised why what I was doing was novel. It may seem strange, and I made a mistake. What I urgently needed to do was to get away from technology and more into what I would call the human field. And I chose to go to Brunel University, which had just stopped being a technical college, had no experience of unconventional research, and which was dedicated to selling the standard technology, in effect. That was actually, now I think about it, the wrong environment for me personally, and for the research. And the research continued, and it got a lot, and I did this educational package, which got very favourable reviews. And I was told by the new head of department to take down all the information on the system because it didn't correspond to conventional AI, so it must be wrong. So I left at the time, which unfortunately we had a family suicide. Why I'm here is a few years ago, my son said, having looked round the house, when I go, I'll have to get a skip. You've got all that paperwork in the garage. It's effectively the whole of one wall of the garage. It's the paperwork, program listings, correspondence, etc., etc. Even the report on which it was closed down by ICL. 2 half-page summaries, one of which didn't say, I don't understand it. The other one who had never come to see me to see what I was doing. And that was used as the basis for closing it down because he wanted to close down the whole department. And I decided, rather than put this whole lot of the skip in advance, I would get back into AI and such like and see where it fitted in. And basically, what I did was to discover that the package that I had suggested for invoicing and later moved on was an unusual type of language. If you take COBOL as a language, it maps the task or the rule for the task into a digital array. What my system did, I'd never heard of neural networks in those days, was map the data and the rules into one language which was mapped onto an array. And if you activated the array by saying these are the active nodes, the answer fell out. It may seem rather simple, that's the problem. It sounds too simple. I don't think anybody else looked at anything so simple. But it did work. So, as a result, let's see what it is. Right. I've been looking at what I would call the standard AI approaches and my intelligent clerk. And the Turing test, it's a lovely test. It sets up a black box. And if you build a system to meet the Turing test, you end up building a black box. I mean, that's what the target is. Now, I started off by thinking, I've got a company in a very complex area, there are 1 million customers, etc. Everything always changing. You want a transparent system. And I started off saying, I don't care a damn about the rules. It must do, whatever it does, it must do transparently. You must always be able to explain. Now, one way of looking at this is that I came up, this is why Pamela and Pinkerton liked the idea. I said, if you alter the CPU, not to address things digitally, but to address them associatively, and alter the addressing in another way, you can make a friendly computer. Because the symbolic assembly language of the computer can be mapped into the way that the humans think about it. And then, in addition, if you look at the big data in the large language model, it uses billions of variables. The system ID said the most important thing is the human must be able to understand what the system does. Now, I hadn't read the appropriate psychology papers at the time. So when I set up the development and started testing, I said, nobody can handle 32 variables in their head simultaneously. But it's a nice easy number to program in. And when I started testing, I found that for most types of applications, and this would apply for the invoicing one as well, was that everything you could do, you didn't need to have active. And active is a critical word, more than about 10 or a dozen variables, usually less, human short-term memory. I built a system, a language system, which was designed, and basically that's the situation in a sense I am now. I'm now writing up a theoretical paper. I have got, I'm afraid it's not online yet, but I've got some listings of an earlier paper, note, which is draft, and if anyone wants this I can give to you later today. And I'm also looking at how this information should be archived. I may well be wrong. I'm a scientist. I know I can be wrong. But it's an alternative approach where at one stage I was told, as I say, your system can't play chess. You know? But I said, what the hell? Early AI was set up effectively. If you look at the earlier papers, tasks which would amuse math students, undergraduates, chess, Go, simple logical problems, etc. I was interested in real world complex problems. And in the list I had earlier of the companies I was in, the first one, when I was acting as a human chatbot, we had some real black swan type events. One of them was a simple complaint from Australia. Your product doesn't seem to be working so well. Sounds simple. It was the first complaint anywhere in the world of a major new insecticide which had been developed to replace DDT. That the pest had become immune. Now that was what started me off, if you like, working from that background. Complexity is what humans are good at. Trying to say we have a limited set of rules, they're useful, but you've got to remember what the limits are. I think that's all I have to say.
Thanks very much, Chris.
Oh, there you go. Hi everyone.